So the thing with binary search is that, I mean, if I show you right over here, first step in binary search you always have to remember is that your array that you're trying to like search or implement binary search algorithm onto, right, that array has to be sorted. So look, my binary search algorithm cannot work on this second line or second array, so I'm going to delete that one. Okay, it has to be sorted, your array. Okay, so our size for our array is 4 because it's 4 elements. Target that we're trying to find, let's make it 3. We're looking for 3. I'm going to be implementing this using a functional approach. I'm going to have a function called int binary search. Perfect. Now I'm going to pass inside of this an array. After passing inside an array, I'm going to say int size, just make it an okay, I'm going to make it size. Then I'm going to say integer, target. I'm going to put in my target as well. So next you want to create two variables, a starting index, so we're going to start at 0, and an ending index. All right, and the ending index, however, is going to be smaller than the size, just one smaller, because it's not going to be size, because size is the actual size of the array, but in C++ we are dealing with our index starts at 0, so that's why it says -1. Now we start a while loop. Inside of the while loop we're gonna keep iterating this while loop, as long as our start is smaller than or equal to end. Okay, because if our start basically ends up getting more than the end, then we want to end the loop. It means that our number doesn't exist. So now I have integer middle. I'm making another variable, alright, and this variable is going to be start plus end, right, and I'm gonna divide it by 2. Why did I do this? Because I'm finding the middle of, how to find the midpoint, right? You add 2 points and then you split them in half. That's going to give you the midpoint. So we want to find the midpoint, and then we want to compare it with the midpoint, right? We want to compare if our array, alright, at the middle index, alright, basically the element that's at the middle index is equal to target, and if it is, okay, then simple as that, return the middle. This is only going to get executed if our element is found in the center of our array. However, if our number in the middle of our array is greater or actually smaller than our target, you can make it anyway. You can make it greater or smaller, doesn't really matter. So anyway, if that's the case, then I want to update my starting index to be the mid plus 1, and if that's false, then I just want our starting index, or actually no, our ending index to be mid -1. And why is that? Because look, the logic here is if our value in the middle of the array, okay, meaning 3, is smaller than the target, so meaning we're looking at 4, then I want the starting to be mid plus 1. So I want you to start looking at 4 and everything above it. So ignore the beginning of the array till the middle. However, the converse is also true. If our mid value is smaller, actually no, greater than our target value, then I want you to just look at the beginning till the middle of the array. Oh yeah, by the way, I forgot, our function needs a return. I mean, because once it exits this loop, I want it to return a -1. -1 means that target doesn't found, because if we don't say return -1, then it's gonna be an infinite loop. It's gonna, okay, what's wrong here now? Oh, I forgot, C++, you cannot make an array like that. Okay, I'm gonna make this size is 4 because our array is of size 4. So you can see it's 1, meaning what did it return? Return meaning that at index number 1 our target 3 is found. Now let me just make the targets 8, okay, because let me just see if it doesn't exist. So you can see -1 meaning it doesn't exist. If I put in a 5, it should give me an index of 4, actually no, of 3. Yeah, so there we go, it gives us 3 because it's saying that at index number 3 our 5 value is found. So yeah, that's this binary search, simple as that. Thanks for watching.